mga math aaral! Welcome to my 6th step-by-step math video tutorial. So in this video, I am going to discuss introduction to logarithms and representing real-life situations using logarithms.
Definition. Let A, B, and C be a positive real numbers such that B is not equal to 1. The logarithm of A with base B is denoted by logarithm of A with base B and is defined as logarithm of A with base B is equal to C. If and only if A is equal to B raised to C. Logarithms can be divided into two types. So we have common logarithm and natural logarithm. Common logarithm is a logarithm with base 10 and it is written as logarithm of x or logarithm of x with base 10. As you can see, we can write or not the base 10. If there's no written base in logarithm, it is understood that the base is 10. Example, logarithm of 25 to the base 10. Logarithm of 16. It is understood that there's a base here which is 10. Natural logarithm is a logarithm to the base e or approximately 2.71828 and is denoted by ln x or logarithm of x to the base e. So if the base is e and it is denoted by ln of x, it is a natural logarithm. Example, logarithm of 400 to the base e. Logarithm of r to the base e. Ln of x plus 3. Example 1. Write the following exponential equations in logarithmic form. So these are exponential equations. An exponential equation can be written as b raised to c equals a, where b now is the base, c is the exponent, and a is the answer of our exponential equation. Rewriting exponential equation to logarithmic form can be written now as logarithm of a to the base b equals c. So as you can see, our base in exponential equation is also the base in our logarithm. And our exponent in exponential equation is the answer in logarithmic form or logarithmic equation. And the answer in exponential equation, which is denoted as a, is the logarithm or it is written beside the logarithm. So let's have letter A. 5 cubed equals 125. So our base here is 5. And the base of logarithm is also the base of exponential. So 5 now can be written as logarithm to the base 5. Next. A now, here is the answer in the exponential equation. And this answer is written beside the logarithm. So we have logarithm of 125 to the base 5 equals c. Equals c. Our c in the exponential equation is our exponent. So the exponent here is 3. So here it is equal to 3. So this is now the logarithmic form of the exponential equation. 5 cubed equals 125. We have logarithm of 125 with base 5 equals 3. Let's have letter B. Our base here is 7. So it is also the base of our logarithm. So base is 7. Then A here is the A of our exponential equation, which is the answer 1 over 49. So it is written beside the logarithm, or it is our logarithm, equals C. C here is the exponent. So negative 2 is the answer in the logarithmic form. So we have logarithm of 1 over 49 with base 7 is equal to negative 2. Next, letter C. So our base in the exponential is 10. So it is also our base here. And A here is the answer in the exponential. So 100. Then equals C, equals, our C is the exponent in the exponential. So 2 equals 2. So we have now logarithm of 100 with base 10 is equal to 2. Next, our base is 2/3. So our base in this logarithm is 2/3, and the exponent is always the answer of the logarithmic, so equals 2. And 4 over 9, which is the A here, is the A beside the logarithm, so we have 4 over 9. So we have now logarithm of 4 over 9 with base 2/3 is equal to 2. Next, the last. Our base is 0.1. So we have our base in logarithm is 0.1. And our exponent in the exponential equation is always the answer in logarithmic form. So we have here negative 4. And the answer in the exponential equation is always the logarithm of in the logarithmic form. So it is written beside the logarithm. So we have logarithm of 10,000 with base 0.1 is equal to negative 4. Example 2. Rewrite the following logarithmic equations in exponential form. So this example 2 is the vice versa of example 1. We are now going to rewrite logarithmic equation into exponential form. Logarithm of A with base B is equal to C. So our base and C is written as B raised to C equals, our A here is the answer in the exponential form. Let's have example A. Logarithm of M equals N. So as you can see, there's no base here, but it is understood that our base here is 10, and it is called common logarithm. So the base in the logarithmic equation is also the base in exponential equation. And C here now will be the exponent in exponential form. So our B here is 10, then our C is N. So 10 raised to N. Then our A here, which is M, is the answer in the exponential form. So we have now equals M. So 10 raised to N equals M is the exponential form of the logarithm M equals N. Let's have the next. Logarithm of 81 with base 3 is equal to 4. Our B is 3. And our C is 4. Can be written as B raised to C. So we have now 3 raised to 4 equals our A here, which is 81, is the answer in exponential form. So we have now 3 raised to 4 equals 81. Next, logarithm of 64 over 27 with base 3/4 is equal to -3. So we have now B raised to C. Our B here is 3/4 and our C is -3. So we have 3/4 raised to -3. Then, our A here is 64 over 27 and it is written as the answer of the exponential form. So we have now 3/4 raised to -3 equals 64 over 27. Next, logarithm of 2 with base 4 is equal to 1/2. Our B is 4 and our C is 1/2. It is written as B raised to C. So we have 4 raised to 1/2. And our A here is 2. So as you can see, it is written as the answer in exponential form. So equals 2. So we have now 4 raised to 1/2 equals 2. Next, the last. Logarithm of 0.001 with base 10 is equal to -3. Our B is 10 and our C is -3. It is written as B raised to C. So we have now 10 raised to -3. And it is equal to our value of our A, which is 0.001, equals 0.001. So we have 10 raised to 3 equals 0.001. Let's have example number 3. Find the value of the following logarithmic expressions. A. Logarithm of 32 with base 2. So what will be the exponent of base 2 to get 32? So we have 5. So 2 raised to 5 equals 32. Letter B. Logarithm of 729 with base 9. So what will be the exponent of 9 to get 729? So we have 3. Because 9 raised to 3 is equal to 729. Next, logarithm of 1 with base 7. So what will be the exponent of 7 to get 1? Equals 0. So 7 raised to 0 is equal to 1. Letter D, logarithm of 5 with base 5. What will be the exponent of 5 to get 5? So we have 1 because 5 raised to 1 is equal to 5. And the last, logarithm of 0.001. We all know that if there's no written base, it is equal to 10. So our base here is 10. So what will be the exponent of 10 to get 0.001? We have -3. So 10 raised to -3 is equal to 0.001. Let's have applications of logarithms in real life. Some of the most applications in real life of logarithms are the Richter scale, sound intensity, and pH level. Logarithm in earthquake magnitude on a Richter scale. The magnitude R of an earthquake is given by R equals 2/3 logarithm of E over 10 raised to 4.40, where E in joules is the energy released by the earthquake. The quantity 10 raised to 4.40 joules is the energy released by a very small reference earthquake. Logarithm in sound intensity. In acoustics, the decibel level of a sound is D equals 10 logarithm of I over 10 raised to negative 12, where I is the sound intensity in watts square meter. The quantity 10 raised to 12 watts per square meter is least audible sound a human can hear. Let's have example. Suppose that an earthquake released approximately 10 raised to 12 joules of energy. What is its magnitude on a Richter scale? How much more energy does this earthquake release than the reference earthquake? So for the solution, our given is energy is 10 raised to 12 joules. So our formula is R equals 2/3 logarithm of E over 10 raised to 4.40. To solve for R, just substitute the value of E from the formula. So our E here become 10 raised to 12. Then copy 2/3 logarithm and over 10 raised to 4.40. So dividing these two, 10 raised to 12 divided by 10 raised to 4.40, just copy the base which is 10 and subtract the exponents. So 12 minus 4.40 is equal to 7.6. And logarithm now of 10 raised to 7.6 is equal to 7.6. Multiplying it to 2/3, we have approximately 5.1. Thus, the magnitude of the earthquake is approximately equal to 5.1. So to compare the energy released by the given earthquake with the energy released by the reference earthquake, just divide the two energies. That is, this one, 10 raised to 12 over 10 raised to 4.40. Dividing these two, just copy the base which is 10, then subtract the exponent. So 12 minus 4.40 equals 7.6. Then 10 raised to 7.6 is approximately equal to 39,810,717.06. This means that the earthquake released approximately equal to 39,810,717.06. Example number 2. The decibel level of a sound in an office is 10 raised to negative 6 watts per square meter. What is the corresponding sound intensity in decibels? How much more intense is this sound than the least audible sound a human can hear? So solution. Our given from the problem is 10 raised to negative 6 watts per square meter. Just substitute I in the given formula. D equals 10 logarithm of I over 10 raised to negative 12. So, pinalitan ko na yung I dito ng 10 raised to negative 6. Dividing this, we have to just copy the base which is 10 and subtract their exponents. So, negative 6 minus negative 12 is positive 6. So, logarithm of 10 raised to 6 is equal to 6. So, 10 times 6 is equal to 60. So, the corresponding sound intensity is 60 decibels. So, for how much more intense is this sound than the least sound a human can hear, we have this solution. Just copy 10 raised to negative 6 over 10 raised to negative 12. Dividing this, just copy the base which is 10, then subtract their exponents. So negative 6 minus negative 12 is positive 6. So 10 raised to 6 is 1 million. So we have 1 million times more intense than the least audible sound a human can hear. Logarithm in acidity and the pH scale. The pH level of a water-based solution is defined as pH equals negative logarithm of H plus, where H plus is the concentration of hydrogen ions in moles per liter. Solutions with a pH of 7 are defined neutral. Those with pH less than 7 are acidic, and those with pH greater to 7 are basic. Let's have example. A liter solution contains 0.00000001 moles of hydrogen ion. Find its pH level. So, solution. Since there are 0.00000001 moles of hydrogen ion, then its concentration is 10 raised to negative 7 moles per liter. Thus, the pH level is negative logarithm of 10 raised to negative 7. And logarithm of 10 raised to negative 7 is negative 7. Multiplying the negative, so negative times negative is equal to positive 7. Thank you for watching mga mat-aaral. Please don't forget to share my video and subscribe to my YouTube channel. Thank you. Until next time, God bless.